department to come closer to our vision of the autonomous factory. I'm here together with my colleague Florian, and he's from the pre-sales department. We are not that experienced, or I'm not that experienced with ROS like Florian or you, but we had a challenge I would like to show you now, and we tackled this challenge with ROS. First of all, to give you an impression what our vision looks like, I would like to share with you, wrong direction, not true, with you our vision. So please enjoy. Okay, so what you just saw is our vision of the autonomous factory, probably not something you will be able to buy within 20 years, but something what consists of many puzzle pieces, or we call it puzzle pieces. So, for example, you saw autonomous AGVs driving around with flexible safety zones. You saw a flexible production setup orchestrated on its own. And behind all these things, we also see the puzzle piece of an AI controlling one flexible machine, for example. And to come closer to this vision, we have in Nuremberg our so-called autonomous factory lab. So a research platform within factory automation to test prototypes, build prototypes around these puzzle pieces and come closer to this vision of the autonomous factory. It's a highly modular and flexible research plant with plug-and-produce capabilities. So we have a fixed inter-plant logistic where we then can plug and unplug our production resources. You will also see in the picture on the next slide. It's a quite innovative area, at least we think. We generated more than 30 patent applications within this area. But then last year there was Marvin from marketing. We had a meeting with him and he asked us, what's so innovative here? And that hurt us. That hurt me, that hurt my boss, because we think within pre-development department we should be innovative and everybody should see it. But we took a look to our current setup and we realized it does not really fit to the vision you just saw. So if you take a look on the upper part of our current setup, we have a quite fixed inter-plant logistics. We can be flexible within the topology of our plant, so plugging and unplugging our modules, but the intra-plant logistics, so transporting our product we produce in our research plant between the modules, is more or less fixed. So we decided to rearrange our whole plant a little bit, remove some parts of our lab and place there, you see it in the lower part, the matrix setup. We then connect our existing plant with AGVs. So we come closer to this vision you just saw also with AGVs, moving around in our more flexible factory setup. But this more flexible inter-plant logistic now gives us new challenges because our products are transported in our factory with these so-called transport plates. For grasping these plates, we have to grasp these 2 points here on the plate. And you know probably better than me, based on laser-based or laser navigation, you cannot be that precise to grasp this product again and again. And this is where ROS comes into place for us. So what we did, or what mostly Lucas in the front row did, because he is my technical expert here, he built a combination of Siemens technology and ROS and brought this all together to solve for us this problem of grasping this product precisely from our conveyor belts and from our new matrix setup. So, of course, we are an OT company coming from the OT. We have some portfolio already in place to set up an HGV. So some IOs, some drivers, and of course a PLC. So we have a industrial computer capable of running a PLC in one core, and the other 3 cores are free then for, in our case, ROS, of course. So we are running our ROS in the other 3 cores, doing a Aruko localization, localizing how we arrive at the preferred position, scanning the Aruko marker with our GreenSense node, and then move the URO to the referred position. But now we have 2 players in this setup, and our problem is we need somebody who orchestrates this machine. And therefore we decided to use the behavior trees, which are offered within ROS, and then we had still to build a bridge somehow to send the commands from our orchestrated behavior tree to our more or less dumb OT system in the Siemens area. I just see we did a slight mistake there, so we're moving the 2 to the right place. So we are feeding in the community also. But what we did, we used a connector, or we used a real-time connection between our ROS ecosystem in the Linux port and the PLC. So we're using there a shared memory technology called the real-time information backbone to send commands between these 2 parts, or these 2 worlds. So between our IT part on the lower part of the OT part, on the upper part, our Siemens technology. Currently, we are just doing this with some flags, so start driving, stop driving, and so on. But as we realized, this is a quite interesting setup, bringing these 2 worlds closer together. And now we are investigating, should we do more like this? And that's where I would like to hand over to Florian, who will give you a rough impression what we are currently doing and where our project is now leading.
Thank you, Carsten. So, when you're only thinking about buying something from Siemens, you're buying some great boxes here and there, and at the end of the day, you will build together your solution. You will have some safety functions, some IOs, and you will find providers of AGVs, in this case the prototype, but there are also real AGV builders utilizing our technology. You will probably here in this room never buy directly from Siemens. You will always have some sort of factory lines already there. And you here in this room, you're always thinking, okay, this is the Siemens world, and they have the big tier fault on somewhere, and it's doing some safety things, but why does this matter to me? And this is exactly why we are coming here and say, we won't replace ROS, but we see, okay, there might be some solutions that Siemens has solved since some decades ago, for example, topic safety. Why do you guys need to reinvent safety? Wouldn't it be a little bit clever solution to look at? I mean, not only Siemens, there are others also doing it, but taking what is there with the safety part of the PLCs or other industrial-proven solutions and combine it with the ROS code. And this is why I'm also today here. I don't know if I press up or down.
Down.
Okay, thank you. Thank you for consulting me. I want to roughly introduce you the Siemens portfolio, what is today there. This has nothing to do with ROS today. This is just some Siemens products. I mean, we're building trains and whatnot, and washing dryers. We are focusing here on factory automation products that I think are important for you, or can be some sort of significant for you. I started with the hardware part, and I'll talk about this a little bit more in a few seconds, but for me, it's not only hardware that we have. We as Siemens, we also are currently getting more and more a software company. You might not have to feel currently about it, but from an insider point of view, I can definitely tell you there's happening a lot. And I think this will also interest you from a business kind of perspective mostly. And we also have a big simulation environment with lots of different industrial tools that are used day by day. Maybe not so much in a research startup environment, but once you get to bigger corporations, then you might find some tools here and there might be interested what can be a way to bring ROS into this setting. So that's what I'm bringing you today. I want to start with the top part here, the hardware part, the automation part, and like you've seen before, and I've talked about it a little bit already, what are the big advantages from the traditional Siemens factory automation portfolio. First of all, there's safety. So there's a well-defined process of you have your blocks, you combine them, and this is known to the TÜV, and you can go to TÜV and say, yes, this is how we do things, and then you're pretty much easy way to go to get your CE certification, still away, but industrial proven way, I would say. We have also a really big portfolio regarding getting things to move in the motion kind of perspective, and all of our IOs, which are proven with their 24/7, all the year going availability. This kind of setup is also, when you're thinking about selling your solutions to factories or end customers, then they might not be like completely fresh, grown-up companies. They might exist for a while, and they have their maintenance teams. And what do they know since a couple of decades? Possibly this old stuff, which happens to work. But if you thinking about the customers in that way, then you know that they are familiar with that kind of situation. If there something happens, for example, with the safety thing or some IO sensors don't work anymore, they know how to deal with it. On the other side, like on the software side of the hardware world, here we have also an extensive libraries. Like there are a couple of industries, like the automotive industry, for example, where Siemens and especially my part of pre-sales, we had a lot of standardizations efforts. This means you all have modelized software in your head, I think, when you're working with ROS. But this brings also the way for the end customers to produce their new plugins or tier objects in a standardized way, so multiple OEMs can work easily together. More things that I think will directly interest you are, for example, our smart robot library. What is this? I think everybody here in the room can somehow control a robot arm with ROS 2, but I think the most annoying thing for you all are the drivers. When you think about your, there are 200 drivers for just one robot arm, and they all sometimes were good, sometimes were bad, and this is what Siemens, not in the context of ROS, but in the traditional context of industrial platform, they say you can currently, I think, 10 or going to be 30 something, program robot arms with one interface. It's like in one Siemens language you can control any kind of robot arm and say go from here to here. The context here is of course not dynamic, whatever. This is the ROS world. It's for automotive repeating and repeating. This is what is there, but it's an industrial driver. You could access through ROS. And then we have the same basically for HVs. Mobile robots driving around the floor, you always need to do your inverse kinetics, update how the HV was supposed to be. We also have here libraries for you to just use it. This is not some core IP from us. This is a free library you can use and build in your robots and just build on top in your ROS world what you want to do and where your core IP at the end of the day stays. And of course, there's an extensive ecosystem of Profinet drivers doing all sorts of things in the sensory way or in the actual way that you can also access. Then I will go over to the software side. We have here our Industrial Edge portfolio. What does this mean? It's an app store where you can have all kind of Docker-based programs from us. There are some few things in terms of predictive maintenance and stuff like this. But I think what will mostly interest you is that this is also a way, if you are thinking of setting your software based on ROS, if you can run it based in a Docker container, you can also set it here and offer it to an industrial product. Carsten already mentioned that we are also here on the slide before, like how to combine the software assets with the OT assets. I don't want to talk about this anymore, but this is also a product which is a C++ library. You can easily access this and control the whole hardware portfolio. And the last thing I want to mention here is that We also have our simulation portfolio. This definitely doesn't come on the cheapest side of our portfolio, but once you are, like I talked to you about this, if you are working with bigger corporations and thinking about integrating ROS into their simulation toolsets, where Siemens already has one of them, but there are also other companies doing those sort of industrial simulation. Then we have here this thing that I think will interest you a little bit. It's called Zimit. It's a product from us, which is specialized on bringing data into all kind of different industrial simulation environments, where it might also be possible from a data point of view to easily tap in with your ROS architecture. Okay, so this is just about to give you a rough idea of what Siemens can bring to the table. This is nothing that is already on a product level out to interface from ROS. Those are all here products by themselves, and they are used from thousands of customers around the world. But I think, and it would be really interesting for me if you guys can think about this, there is something interesting you, and I would really love to hear more about it in a later on discussion with you. Okay.
So that's our question. So also to you, to the ROS community, if combining these two ecosystems can generate benefits for anybody, because I described it a little bit within our lab. So we experienced within our lab, and it was very beneficial for us bringing these IT and OT worlds closer together. And Florian just showed a lot of other potential drivers we see within our ecosystem. So therefore, we are currently in a so to say investigation phase, better understanding. Should we build something like this? Should we bring a connection like this big plus we can see here in the middle to the community to generate at the end benefit for you also? So this is our invitation to talk afterwards, and thank you for your attention.